April 2024, I took a trip to northwest Pennsylvania to photograph the total solar eclipse, and it was one of the most amazing things I've ever seen.
Take off the glasses. Oh my God.
What I didn't know was that this was just the beginning of a series of rare and incredible events that I would have a chance to experience from close to home throughout the year, courtesy of the sun. The Aurora borealis, the northern lights, took the world by storm in 2024, when the sun's magnetic cycle reached its peak and produced a number of major geomagnetic storms on Earth. Basically, a regular disruption of the sun's magnetic field results in a high occurrence of sunspots on its surface. Those sunspots can produce massive eruptions of magnetic plasma, accompanied by flashes of light called solar flares. The eruption itself is a coronal mass ejection and becomes an enormous wave of electrons and radiation propagating through space at hundreds of miles per second. On Earth, the aurora occurs regularly at high latitudes, as the solar wind is constantly sending charged particles in our direction. Those particles are channeled along Earth's magnetic field lines toward the north and south poles, where they collide with the high atmosphere and energize the gas ions in the air, causing them to glow in giant bands of shimmering light. When a CME strikes Earth, however, a geomagnetic storm occurs, producing aurora visible at lower latitudes. The more significant the CME event, the more widespread the aurora. I first saw and photographed the northern lights in central Pennsylvania the previous April, a total of 3 times that year, and at first I knew next to nothing about them. But I and a lot of other people suddenly became very interested when we learned that Solar Cycle 25 was building to its peak, and it would come to pack a serious punch. I spent months planning for the solar eclipse on April 8, 2024. What would happen just 5 weeks later came with about 2 days' notice. In early May, NASA observed a series of powerful flares on a region of the sun that would soon rotate to face the Earth. Then, the sun fired off multiple X-class flares, the most intense that it can produce, and the resulting CMEs formed an approaching shock capable of generating a historic geomagnetic storm. The forecasts were getting exciting, anticipating at least a G4 level storm beginning sometime on May 10th. The G scale measures the intensity of geomagnetic storms from 0 to 5, and a G4 event would almost guarantee aurora visible from my area, below 45 degrees of latitude. The storm arrived at Earth during the afternoon in the US on May 10th, and would continue for hours, but of course during the day you wouldn't see it. The southern shore of Lake Erie looked to have generally clear skies after dark, so before sunset I hit the road. I was hoping for something similar to what I saw last April, but I had no idea what was actually in store. I reached the marina outside Erie just after the sun had gone down, and by then the storm was well underway. I only had to wait until the sky was dark to see it. It was me, a few people fishing, and a few others waiting for the aurora as well. But as more people started to arrive, I waited with my granola bar and my hand warmer to see what would happen. Until very suddenly, when a heavy surge of energy rained down on the atmosphere, and the night sky turned green. I genuinely couldn't believe my eyes. The night kicked off not with a slow appearance by delicate ribbons of aurora, but an explosion of light and neon color, filling the sky overhead. Even with the light pollution nearby and the bright moonlight shining center frame, the Aurora borealis was clearly visible to the eye, waving and fluttering in gigantic curtains, and it was beautiful. Even looking to the south behind me, I could clearly see it. The plan was to shoot time-lapse segments, individual stills, and coverage with my low frame rate, high ISO camcorder mode. The last one looks kinda awful, but it's better than nothing. A crowd gathered quickly, and soon the fishing beach was filled with onlookers, as reports of aurora sightings flooded social media. Talking with some people throughout the night, I was impressed with how well certain phone cameras could capture the aurora. My phone doesn't have an advanced camera, but it does give a good idea of what was visible to the naked eye. Photos of the aurora are usually more impressive looking than the real thing, especially in lower latitude, light-polluted places, because a long exposure can sense more color and light than our eyes can. The most visibly stunning lights can be seen from remote, totally dark locations at high latitudes, like Alaska, Norway, and Antarctica. From 10 p.m. to about 1:30 a.m., I shot the aurora from the lakeshore, and though I could have done it all night, my batteries were dying and I didn't want to fall asleep at the wheel on the way home. So I finally pried myself away from the spectacle and headed home. However, at a rest stop I checked for updates and saw sudden excitement from photographers anticipating a huge substorm, maybe the biggest of the night. A substorm is a sudden, concentrated release of the aurora's energy that shows up on the Earth-orbiting magnetometers shortly before it arrives. The best show of the night could begin at any minute. I managed to work my way out of the fog and find a vantage point to shoot just a bit more, because what if I never got a chance like this again? Thankfully, I was totally wired with excitement and didn't feel a bit tired until I was home. But at 3 a.m., I stepped out of the car at Goddard State Park in western PA and looked up to see the aurora pulsating and shimmering directly overhead. It takes a rare storm event to bring overhead aurora this far south. I didn't have the gear for good low-light video, but in person, the aurora can pulsate rapidly, in a quick fluttering motion that ripples across the sky in half a second. At this time, there was so much dispersed aurora filling the sky that I had trouble fitting it into my 18mm frame. Overnight on May 10th to May 11th, I observed the northern lights with the naked eye continuously from dusk at 10 p.m. to 5 a.m. This geomagnetic storm, named the Gannon Storm, was the strongest since 2003, rated G5, the highest level on the scale. The northern lights were at least detectable on camera from all 50 U.S. states, and were apparently visible from as far south as the Bahamas. It typically takes roughly 2 days for a CME to reach Earth, so chasing them at lower latitudes requires some short-term flexibility, a dark sky to the north, and cooperation by the weather. I would end up missing a few more noteworthy events throughout the year due to cloudy skies or being asleep, but that wouldn't matter much come October. On October 6th, I was actually in northeast Ohio going after a line of supercell storms. This was the second time this year that I went chasing and missed a significant photogenic supercell directly over my house, but I digress. I was aware of potential for low-latitude aurora sightings that night, if the event could gather enough energy into a substorm. So, after I bagged a decent supercell, I stuck around in the rural countryside. After nightfall, I was shooting the distant lightning over the southeastern horizon when I happened to look over my shoulder and noticed a faint movement in the northern sky. I swung the camera around and sure enough, a brief substorm of deep red aurora pillars was occurring. This was a much smaller event than May 10th, and one you're more likely to see this far south. In person, the pillars were very faint and appeared almost white, visible only during the height of the substorms. Still, it was wild to catch a supercell and the northern lights in the same day, for the first and hopefully not the last time. There were a few days of heightened geomagnetic storming. I don't remember anticipating anything exciting the following day and wasn't prepared for it. but there's not a direct correlation between a storm's power and its potential for impressive displays. The night of October 7th, I was home, and I noticed that the aurora potential was high enough to get chasers excited. The weather was clear, so I walked just up the street, and I found that there was a green glow on camera above the horizon. Not yet visible, but building slowly. Around 10:20, a substorm arrived, as shifting red pillars became evident. The colors of the aurora change with height and between different gases within the atmosphere. As usual, the photos captured much brighter color than the eyes could, and I've seen people online disappointed about how little can actually be seen during low-latitude events. If you're eager to see the northern lights, it's important to consider your vantage point. Not only a dark area, but one also surrounded by dark areas, which you can find using various online light pollution maps. And of course, they get more spectacular the further toward the poles you go. This substorm lasted about 15 minutes before it calmed down. By midnight, the storming had intensified again, and just before 1 a.m., the sky erupted into visible light and color. During these brief episodes of beautiful craziness, I managed to capture 2 meteors flying through the aurora pillars. I got one back on May 10th, but that picture was out of focus, so what were the odds I could redeem myself this soon? I think I can call this one of my all-time favorites. For comparison, here's my approximation of what this moment looked like to the eyes. The visible lights were dim and less saturated, but I could clearly distinguish those amazing strawberry colors. I attempted to shoot time-lapse, but the mist poured out of the fields continuously, and I had to wipe off my lens every few exposures. Overall, a tricky but fantastic experience, and there was still more on the way. If you told me after October 7th that by the end of the week I would catch another Northern Lights event on the echelon of May 10th, 5 months to the day exactly, I'd have said you were a fool and a charlatan, and to get out of my house. But as it turns out, the sun was not finished racking up shutter actuations on my aging camera. Another serious geomagnetic storm was on its way, and it would achieve G4 status. The Space Weather Prediction Center issues alerts ahead of events this big, because beyond pretty lights in the sky, they can have damaging effects on our infrastructure. Exceptionally powerful storms in the past have caused power blackouts on the ground, disrupted GPS navigation and radio communications, and even caused satellites to fall out of their orbit by changing the density of the outer atmosphere. In the meantime, the agency also posts graphics designed to show what the extent of the aurora could potentially be. Again, there is not a simple correlation to storm strength, and there are many small details that can influence the aurora spread. But a G4 level storm will certainly produce major aurora somewhere. So it was time to head back to Lake Erie. The crowd this time was bigger. If this proved to be a good one, I planned to really concentrate on quality time-lapse photography. It's exciting watching the reports of low-latitude aurora come in, as the daylight terminus slowly works its way west toward my location, eagerly waiting for the sky to darken to find out what's already occurring just behind the veil of twilight. Except this time, I really didn't have to wait, because before the orange light of sunset had even faded, I could already see it. It was then that I knew tonight was about to be wild. Oddly enough, almost everybody I talked to out of the crowd tonight was from somewhere other than the US. It sounded like Latin America, East Asia, even Scandinavia, famously the world's Aurora destination. I have to believe they were all here by chance and they didn't come to Pennsylvania to see the northern lights, but all their reactions were pretty much the same. Awe and excitement. Some staring speechless up into the sky, others literally jumping for joy at the pictures they were taking. Due to the early start, I was able to shoot the aurora for about 6 hours. From dusk, it gradually built in intensity to a vivid substorm at 10 p.m. Thankfully, the sky cleared, because what the substorm left behind was a concentrated front of ionization current, shimmering and coiling over distant Ontario. As if it wasn't spectacular enough, the sharp line slowly started to unfurl into a dazzling display of chaotic ribbons, and they soon overspread the northern sky, pulsating in gigantic, impossibly fast rippling movements. I wasn't able to capture the real-time spectacle, but witnessing this incredible cosmic accident in person is an unforgettable experience. This event that's so large and all-encompassing as to be almost overwhelming, yet ethereally beautiful in a way that it seems designed to be so. Once again, here's my naked eye approximation. Clearly visible with noticeable color. I had a hard time catching good storms in 2024, but other skywatching events completely stole the show. From the solar eclipse, to the comet A3, to my first big-time aurora experience. Space weather can be even harder to figure out than Earth weather, but well into 2025, we're still feeling the effects of the solar maximum. So if you want to learn how to chase the northern lights, there's no shortage of informational material from other photographers and scientists online. I won't pretend to understand all of it, but I aim to keep learning on the go. In this age of misinformation, conspiracy theories, and science skepticism, I hope the aurora events of 2024 served to inspire more curiosity and fascination toward nature than fear over alternative theories like the Earth losing its magnetic field. Approach the world around you with an open mind and a willingness to learn, because it's got plenty of amazing things to show you.